Hello, my name is Mindy Chen. I am the Director of Decision Science at Hudl. I will be sharing with you how I grew Hudl's data team from 3 to 20 people. First, a little about Hudl. Hudl is a sports video sharing and analytics platform. We help coaches and athletes win by letting them upload game video, do breakdowns and analytics so they can identify their own tendencies, learn from coachable moments, and generate highlights. We work with 95% of U.S. high schools and colleges and more than 100,000 teams across 30 sports globally, from some of the biggest professional clubs to grassroots youth teams. All of this means we produce a lot of data. The team at Hudl that works to make sure this data is at the heart of decision making is Decision Science. We are a team of 4 data engineers, 1 analytics engineer, 8 data analysts, 4 data scientists, and 3 consumer insights researchers who are all united under one roof. I think that the key to our success is our diverse skill sets and our shared mission and mindset. I have the privilege of leading this team. This slide shows aspects of my background to give you context on me. As you will see, my approach to data is highly impacted by my background in engineering, product management, and consumer insights. Our agenda is, let's relive Decision Science's journey as a data team together to set the stage for learnings that will help you benefit from our experiences. We went through 3 distinct stages in our growth, and as we talk about each, I will call out timelines to help you orient as to when each stage was happening. For each stage, I will also try to touch on how our team was structured, our tech stack at the time, the type of analytics that we did, and the challenges that we faced. The first stage was roughly 2015 to 2016. This is when we set up a data warehouse and started to provide ad hoc reporting. During this phase, we started with 3 engineers who wanted to experiment with standing up data ingests and building a data warehouse. We found a couple of Hudlies with analytics backgrounds and started taking data requests from all areas of the business. During this stage, these 2 functions lived on separate teams, but we were united by our determination to put data at the forefront of decision-making at Hudl. This was our tech stack at the time. We built our data warehouse using Redshift and wrote our own ingests to bring data into the data warehouse. Our first analytics environment was Redash, a SQL editor-based BI tool. One major assumption we made when starting up the data practice was that everyone can learn to query data using SQL. At the time, Hudl was much smaller than it is now and had mainly engineers, so this assumption made sense. But as Hudl grew, it quickly became a deterrent to data usage. Product, marketing, sales, and other functions were forced to learn SQL in order to access data. This led to 2 problems. Some folks never felt comfortable pulling their own data and waited in line for data analysts' help. Despite growing the data analyst team from 2 to 5 people, there were still long breadlines of people waiting for help and then giving up. Another group of folks learned SQL and went about confidently pulling their own data. What they didn't realize was that even though they took 2 SQL classes, their SQL was still wrong. And on top of that, the data they used was also wrong because they didn't fully understand the nuances of that data. People got different answers depending on what data they used, but nothing alerted them to those pitfalls or stopped them from pulling and using that data to make decisions. This is what we started calling the illusion of competency. Let me show you what this looked like. Hudl is a SaaS business driven by product usage. Bob is an account manager at Hudl who wants to find teams that haven't been using Hudl so he can reach out to make sure that they're set up to get value out of Hudl. He can either wait in line for data analysts to pull the data, or he can try to do it himself. And since season is starting, he can't afford to wait, so he tries to pull the data himself. He wants a list of American high school football teams that haven't exchanged film for 60 days or watched video for 30 days. This is basic information to Bob's job, but getting it is prohibitively difficult. He has to write 149 lines of SQL, and every line is fraught with opportunities for error. That's why we said we have to democratize data, and this became a focus for us starting around 2017. Democratizing data is a buzzword, so let me tell you how we define it. To us, democratizing data means to provide independent access to trusted data. It starts with trust. If people don't trust the data, they will not use it. During this stage, our focus shifted away from answering ad hoc questions to building out the most important domains of data to the company as curated data models that people can trust. We invested in data quality by working with teams producing data to clean up source data problems, rather than maintaining band-aids for them. And we improved our own dev and testing practices, tooling, and environment. Once we have trusted data, we set out to enable self-service. We stopped expecting everyone to learn SQL and moved to a BI tool that enabled click-and-point data exploration. The result was an easier interface where people can confidently self-serve data that they can trust. And here we see Bob, our account manager, pulling the same list as in the previous video, except he doesn't have to write SQL in this one. Compared to that, click-and-point exploration makes it easier for Bob to do his job. To democratize data, we added Looker and dbt to our stack. We used dbt to model data and Looker as our click-and-point BI tool. Our team also evolved during this stage. We combined data analysts and data engineers into one team because we recognize that teams working on the same value chain, so in this case, delivering insights through data, belong together. This move improved prioritization, communication, and alignment across our team. We added data scientists to our team because as Hudlys got insight and in hindsight through reporting, they naturally wanted more foresight. The first project we chose to deliver here were identifying predictors of renewal, which is core for Hudl to understand because we are a SaaS business. Since the focus for most of the team shifted away from ad hoc analytics to creating curated data models for self-service, we funneled data requests that were not yet self-serviceable into a rotations-based analytics support function. Analytics support addresses quick turnaround requests like retention analysis for products or user identification for marketing campaigns. Analytics support helps us keep a pulse on the data needs and trends across the company and illuminates which areas of data to target for self-service next. We also started embedding individual team members with business areas. Our goal was to shift away from being order takers to being business partners. To do that, we had to start building business domain expertise and deeply understand the needs of our partners. We added consumer insights research because we wanted to understand the intentions behind customer behaviors and what to do about it. Consumer insights is a discipline that uses qualitative research, like interviews, and quantitative research, like surveys, to understand how the customer thinks and feels. They analyze human behavior to understand what our customers want and need, why they feel this way, and what to do about it. Here, for example, our consumer insights team summarized research findings into an infographic to help Hudlys understand how athletic departments consider the affordability of the new athletic director package. This was to support Hudl's strategic push to win the school, meaning sell to the entire athletic department instead of to individual teams. During this phase in our growth, Hudl had grown from 300 to over 800 employees, acquired 4 companies, and expanded globally. We were trying to keep up with Hudl's usage of data, but ran into this brick wall of scaling issues. Our ingests, which started out as MVPs to see if we could stand up a data warehouse, began to fail because we never anticipated the load that we would experience. All our data was in Redshift, and warehousing costs were growing beyond what we were comfortable spending. Democratizing data reduced breadlines, but building data models to enable self-service was taking a long time, and we didn't know how to move faster. The way we modeled data also made those models difficult to change and test. During this time, I literally felt like our world was being held up with duct tape and string, ready to crumble at any moment. Which brings me to the third stage in the evolution of our data team, scaling our capabilities. Let's start with how we scaled the decision science team. Around this time, I kept wondering, is decision science right-sized for Hudl? To answer this question, we did industry research and learned that many organizations have a data team size that's around 3% of headquarters size. Hudl has about 800 people in core corporate functions, so we were about 2.5% of that. We had plans to grow our team to 25 people this year, but I knew that kind of growth trajectory is difficult to sustain. How can we keep up with Hudl's needs without having to scale linearly with company headcount? To me, it started with removing inefficiencies in how we operate by getting the team structure and composition right. Our experience and industry resources both point to a ratio of about 1 data engineer to 1 analytics engineer to support every 3 data scientists and data analysts. So we invested in the data engineering and analytics engineering functions. They are force multiplier roles that help us scale by making everyone else more efficient. We were set to grow to 3 analytics engineers before COVID hit, but integrating even the first analytics engineer into our team pushed us to get clear about the areas of ownership for data engineers, analytics engineers, and data analysts. This is an early diagram that we use to evolve our thinking around how each function contributes to the entire value chain of delivering insights through data. Don't worry about reading everything on this diagram. I just wanted to show you how we were starting to map out which role owned and did what as we move towards greater role clarity. This is still a work in progress for us. Also, to help our team scale, we expanded analytics support to dedicated instead of rotational staffing. This was a deliberate move to funnel one-off data requests to this team so we could free up everyone else to shift to deeper partnership work. We also expanded our data science team because we saw many opportunities to apply predictive analytics and machine learning to solve business problems. The more domains of data we modeled, the more cleansed data we had to feed this work. But we weren't realizing the full potential of our work in this area, so we dedicated one of our managers to focus on growing our data science practice. In the previous stage, we embedded lone analysts within business areas. We liked the benefits of partnering closely with business areas to drive decisions and actions through our work, but embedding solo analysts left them feeling isolated. So we moved from embedding individuals to embedding teams. That way we can align everything we did with the needs of our business partners and reduce the sense of isolation. Remember the duct tape and string that I felt was holding up our environment? Let's talk about how we dealt with that. In 2019, we had been operating a data ecosystem for about 4 years and had reached a scale and rate of growth that we knew was not sustainable if we did not take action. This slide lists some key parameters of the data ecosystem that we were operating at the time. Our data warehouse was querying close to 200 terabytes of data and supporting an analytics workload of about 5,000 queries a day. This was exciting for us. We had achieved an impressive amount of growth. But what would happen if we kept growing at that rate? The red line in this chart forecasted unbounded exponential growth in our data warehouse volume. The cost to keep up with that was just not palatable to us. Making this problem worse, we were starting to ingest high-volume streaming data from our Snowplow pipeline, which made it even more urgent that we find a way to scale. This is what our environment looked like at the time. We had more than 25 bespoke ingests feeding data into the data warehouse, which then fed our BI tools. The data warehouse was weighed down by all our data. It served both analytics workloads from people modeling and querying data and ingest workloads to bring in data from source systems. Everyone shared the same bandwidth, so what one person did affected everyone else. We did not have any more bandwidth to give to high priority workloads. We also had to pay the same amount for every piece of data in the data warehouse, regardless of its usefulness. Our solution to these problems was to migrate from a data warehouse-centric to a data lake-centric ecosystem. We reduced our data warehouse footprint by offloading data to the lake. We kept only high availability, low latency access data in the warehouse. For us, this meant important data about teams, schools, their subscriptions, and their activities on Hudl. Moving lower value data to the lake improved our cost structure because we only paid warehouse premium for the most important data. We also reduced our multi-tenant problems by migrating ingest workloads off the data warehouse and keeping only analytics workloads there. Before, we could only use our data in the data warehouse. Now we can fan out data from the lake to other downstream applications. We can set up a transactional pipeline to integrate data back into the product or support different machine learning workflows. These downstream options took even more load off the data warehouse and unlocked more use cases for our data. Besides migrating to the lake, we also scaled our data ecosystem by rewriting our ingests using industry standard tools and reusable patterns. We set the expectation that every new ingest had to improve quality, scalability, and reliability, be easier to iterate on, and enable downstream discoverability by cataloging the data ingested, all for the same cost as before. Sounds impossible, but we've actually been able to achieve this through standardization. This is a busy diagram. Don't worry about reading everything on it. It just shows that before, our ingests had no standardization. They were all bespoke. We solved the same problem in many ways using different tooling, as you can see from the tons of colors on this flowchart. Each color represented a different technology or data format in our old ingests. Having each ingest be a different pattern with its own tooling increased cognitive overhead and operability costs. Multiply that across 25 different source systems, and that's a lot of overhead. This picture shows what dealing with a crumbling infrastructure felt like for our data engineers. During the day, customers would complain to them about jobs that kept failing, forcing work to stop while they reloaded data, while posting to a dozen public Slack channels, telling everyone that the data we have is wrong. And at night, they were woken up several times a week by legacy jobs. To scale, some of these jobs required them to remember a dozen steps that they had to execute in a precise sequence or risk significant data loss. This was the data engineering team working all through Easter Sunday because they finally got a chance to do new development, but then ran into unforeseen fires because there was no workload separation, codified infrastructure, or CI/CD in our immature environments at the time. The human cost was our biggest motivator to change. Our change began with re-architecting ingests to follow a standard pattern, as you can see from the process flow at the top of this diagram. We deployed vendor solutions where possible to minimize the number of ingests that we had to write. Where we had to create custom pipelines, we applied the same patterns and tooling to lower cognitive overhead and operating costs. As we migrated ingests to this new architecture, we also put an emphasis on building better capabilities by improving validation, enabling data cataloging, and making all ingests lake first. The biggest benefit was a data engineering team that could apply their talents innovating for the future, instead of being hamstrung by the burdens of the past, as Addison, one of our data engineers, describes here in this Slack post. Their efforts replaced duct tape and string with solid scaffolding. These are the industry standard tools that played a role in scaling up our data ingests. As I mentioned earlier, starting in 2017, we began modeling data for self-service. The way we modeled that data, however, was not scalable. When we worked in ad hoc analytics, we answered isolated questions by creating single-purpose datasets that were usually overlapping, conflicting, not optimized, and difficult to test and maintain because they lacked shared foundations. Over the last few years, we made an intentional move towards unified analytics, where we built shared foundational data assets designed to enable cross-cutting analytics using shared business constructs. So let's see what this looks like in practice. This diagram shows that when we were doing ad hoc analytics, we created a distinct dataset for each question that we were trying to answer, represented by the blue boxes. These datasets had little reusability because they were only designed to answer that question. We also represented Hudl's core business constructs differently in these datasets. In the 3 blue boxes, you see slightly different versions of teams, activities, and subscriptions data. This contributed to disunified analytics, where people got different answers depending on how they looked at the data. There was no standardization around these business constructs that are core to understanding Hudl's business. We tried to stand up common definitions when we created models for self-service. However, in order to build out everything that anyone needed around a domain of data so it could be self-served, we created these massive denormalized tables with dozens of columns to accommodate specific aggregations that business users needed. It's not surprising that everyone was afraid to touch these models. Nobody quite understood all the logic within them. Changes had unintended side effects, and the true grains of these data sets were obscured by layers of complexity, making them difficult to test and maintain. We began re-architecting our data models using the same engineering principles behind our ingests: abstraction and reusability to enable scalability. Our analytics engineer led the charge on this movement. The yellow boxes show that we now represent standard business constructs, such as teams, users, activities, using facts and dimensions. We can combine these facts and dimensions in different ways to deliver insights, as shown in the blue boxes, and still have unified analytics because they pull from standardized business concepts. Having these smaller, modular intermediate tables, like the ones in yellow, also made them easier to maintain and test. To wrap up this section, one of our team's learnings is that we should have put more energy into planning for scaling from the start. We should not have waited until we ran into brick walls to take action. We're now on a solid trajectory. I don't feel like we are held together by duct tape and string anymore, but we paid the price for thinking about scaling too late in the substantial effort that it took to get here. One of the most important lessons you can take away from our experience is to ask yourself how your system will scale before you start building, and keep that question in the forefront as you build and operate. Let's talk about other things that we learned that you can benefit from. We have learned to prefer depth over breadth. So we started a data practice by hanging up our shingles, inviting anyone with a question to ask us for help. This gave us visibility into the extent of data needs across the company, but it didn't enable us to go deeply enough with any one business area to move the needle. Our focus was scattered by trying to help everyone a little, so we couldn't help anyone a lot. In retrospect, if we could do it all over again, I would find one business partner to work with so that we can wrap our minds around their problems and demonstrate early wins by solving those problems, which in turn would generate momentum for more partnerships. Our team has also learned to prefer a vertical to a horizontal approach. So what do I mean by that? The horizontal approach is, let's ingest all the data from multiple data sources into the lake so we can do stuff with it. Maybe we're not even sure what stuff we're going to do, but it'll come into use someday. Then let's model it all and try to provide as much self-service reporting as possible on that data. Because we're tied up ingesting and modeling data, we don't have time to provide deeper analysis or predictive insights. The problem with the horizontal approach is you never get beyond ingesting, curating, and cleansing data. If you're like us, your data is ever changing. There's always something in these bottom two layers to keep you busy. And if you have to work these two layers down to nothing before you walk up the data maturity curve, then three things will happen. First, you will likely be doing work of diminishing returns. Second, you will never mature beyond addressing basic needs. And third, your team will be frustrated and capped in their growth and development. Our team has learned this the hard way. So we've moved to a slice of value vertical approach. Similar to how we can choose to move the needle with one business partner instead of helping everyone a little, we can take one slice of value, start with the outcome, and work backwards to implementation. Because the key to a small data team's survival is demonstrating value quickly, choose the slice that solves the biggest problems for the company. Ingest and model only the data necessary to solve that business problem, and then go as far up that slice of value as possible. At Hudl, one of the highest value verticals we can tackle is to help the organization win the school. As I mentioned before, Hudl is shifting from selling to individual teams to an enterprise model of selling to a full school. Our high value problem here is, how do we get more existing customers, teams, to upgrade to the new full school package? To support this outcome, we need subscriptions, activity, and team data. We start by only ingesting that data. Next, we model that data so we can report on which schools have upgraded and which haven't, and their usage profile. But we don't stop there. With the same data, we can tell product which features are heavily used by teams before they upgrade. We can interview schools to understand what plays into their upgrade decisions. We can go farther by telling leaders what factors are statistically predictive of whether a school will upgrade. We can also guide marketing and sales outreach efforts by assigning each school a probability of upgrading. We can go as far up the vertical as possible to deliver on that slice of value. And when it comes time to select the next data set to ingest or model, we can choose based on what that data adds to existing slices and also what new slices it unlocks. This is what I mean by preferring a vertical to a horizontal approach. One question you may have is, what have we learned from growing decision science that can inform starting up a new team? What roles should be in it? In what order should more specialized roles be added? So let's talk about that. Most new data teams start with a data analyst or a data scientist, depending on the focus of the team. And if this is your situation, you are likely looking for a full stack data analyst or scientist who can take on some data engineering, especially with the help of tools. And this is increasingly possible because the ingest tooling space has matured. You would add a data engineer if you have a data source that's not supported by an ingest tool and you need to build custom ingests, or you need to build a custom machine learning pipeline, integration pipeline to feed data back into the product. You would also add a data engineer if you have data that requires special transformations or you reach a scale where a tool-based approach is more costly than a do-it-yourself model. You would add an analytics engineer when you need dedicated effort to making your data architecture and infrastructure scalable. My learning on decision science is that we waited too long. I would recommend that this be one of the first few roles you hire. The reason is analysts and data scientists are typically not engineers, and it takes an engineering mindset to think about evolving platforms and data architecture. This is critical to get right from the beginning because it sets the stage for effortless instead of painful growth. You would add a consumer insights researcher when you want to go beyond describing and predicting to explain why and what to do about it. Rarely do I see qualitative data roles represented on data teams. But combining qualitative with quantitative has been such a core part of our team's success that I will share an example later of why this is a valuable combination. If you do decide to start with a full stack analyst, data scientist, recognize upfront that it will be difficult to find someone who wants to ingest their own data, set up their own data analytics pipelines or machine learning pipelines, put energy into designing the right data architecture, partner with the business, and provide reporting, insights, and predictions on top of that. And even if you do find that person, it can be a gamble. We've lost data scientists who had to play a jack of all trades role in the early days of our team's evolution. Their morale suffered because they didn't get to use their specialized skill sets. So you need to make sure that you find someone who is open-minded and willing to do a lot of different things. You also need to keep in mind that as the team grows, you will ultimately need to trade off focus and specialization. Just because someone can do everything doesn't mean that they should do everything. What is the best use of their time? At some point, you will also wonder, is a generalist good enough, or do we need to get the dedicated expertise and focus of a specialist? Whether you go with a generalist or specialist, you should push them to use industry standard tools and building blocks. Let me expand on this. Our team has learned to avoid reinventing the wheel. We rely on industry standard tools and building blocks to speed our time to market and free us up to do higher value things. This has been key to our ability to scale. You will always have team members that want to create everything from scratch. Doing that is fun, but it results in higher than necessary operational overhead. Not everyone who wants to create from scratch also wants to maintain what they created, harden it to scale, because it's more fun to move on and create the next thing. Eventually, the accumulated operational burden of the things created but not hardened will become a crumbling foundation held up by duct tape and string. I have firsthand experience of this, so my advice is to prioritize building with what's available and differentiate only when absolutely needed. Then make sure that you're staffed to support what you build. Hudl, being a decentralized organization with autonomous teams, is a challenging environment for data governance. Unlike traditional organizations where there are committees that make the rules about the data and no one can violate those rules because data is locked down, operating in our environment has taught us to codify governance. At Hudl, there are no limits on who can produce and use data. And we pride ourselves in that. So we have learned to rely on systems instead of people as much as possible to codify data governance. For example, we used to train all new hires not to select star from logs. This is a massive unstructured table that degrades performance for everyone else if someone does select star from logs when querying the data warehouse. Think about how unscalable that is. If we miss training just one person, or if one person forgets, in a shared compute environment, everyone suffers. The way that we codify governance around this is by enforcing workload management rules that stop long-running queries in Redshift, so they cannot consume excessive bandwidth. This engineers in fault tolerance as a systemic solution to a collective action problem. To take that up a level, instead of constantly educating people on what to do and counting on them to remember to do it, we chose to rely on systems to enforce the right behaviors. Another example is handling unstructured plain text application logging. If you have this type of data, then you feel my pain. Logs come in non-standard formats that you have to regex. They're missing key context. They can change without warning. The devs producing the data are not even aware of the downstream impact they're having. Meanwhile, data people are mad at developers for messing up analytics. The solution isn't to gate every PR before it can be merged. In any company of size, that isn't doable. The solution is to migrate user activity tracking to a system that enforces schema definitions up front, schema validation on ingest, and schema versioning, with changes kicking off a review process. This is what we use the Snowplow pipeline for, because we believe that codified governance is governance that can scale even in the most decentralized organizations. The side effect to how we have democratized data is now everyone comes to us asking for a dashboard and looker. Instead of telling us their needs, they tell us the very specific solutions that they want us to just go and build for them. The decision science team has been evolving away from being order takers to being consultative business partners. So this means that when someone asks us to build a dashboard, we don't just take that as a given. Instead, we work to understand their need so we can apply our own judgment and creativity on how best to meet that need. Remember Bob, our account manager from earlier? Well, Bob really digs Looker now, and he wants us to build him a dashboard that puts all of the data for all of his accounts at his fingertips, so he doesn't have to go hunt for that information when contacting those accounts. We can build Bob exactly what he asked for, a big dashboard with all the information he wants. But the problem is, this dashboard has so much on it that it's informational overload for Bob, and it slows him down rather than speeds him up. He has to separate the data that matters from the data that doesn't matter when deciding whom to call. Okay, so let's take the guesswork out for Bob then. By building a predictive model and giving Bob a dashboard of only the activities that we know are statistically predictive of renewal. But why stop there? Instead of a dashboard, we can give Bob a prioritized list of counts to call based on renewal predictions or algorithms used by other successful account managers. Delivering insights this way makes it easy to iterate on the algorithm under the hood to find what works best. And if we really want to get ambitious, we can automate a portion of that call list. So for example, customers that are likely to renew anyway for automated outreach, so Bob doesn't even have to make a call, saving him even more time. This example shows that we can solve problems in smart ways that our customers don't realize are possible, but only if we figure out what they need first and not just build what they request. So we've delivered the call list for Bob. Now what? How do we judge success? Our team measures success not by what we produce, which we call our output, but by what outcomes our business partners are able to achieve using what we produced. We call this going all the way to the right. And when you see the next chart, you'll know what I mean. We've built the call list for Bob, set up automated outreach for accounts that were highly likely to renew without intervention. That's our output. That's what we have delivered. But that's just the beginning. We want to know if Bob is actually getting use out of the call lists and if it's saving him time. We push ourselves to use data to measure the adoption of our data products. We also reject the mindset that all we can do is deliver the goods. Whether someone uses it is outside of our control. We believe that if Bob isn't using the call list, it's our job to find out why. If the data is wrong, we have to fix it. If the list is hard to use, we have to improve its usability. On top of that, we want to build a pathway that gets analytics and insights to the edge, where it can impact day-to-day operations. So we're not just building this only for Bob. There's something in it for us too, and we have to put just as much stake in seeing it succeed as he does. Let's say that we iron out all the kinks and Bob is happily using the call list. We don't declare victory there. If he's using it but renewals are not increasing, then we still need to go back to the drawing board and ask why. Are the predictions incorrect? Is the underlying algorithm or delivery mechanism flawed? Are seasonality effects obscuring measurement? Similarly, we have to make sure that offloading accounts to low touch doesn't hurt renewal on those accounts. Ultimately, if we are successful with Bob and we can apply those learnings to improve the company's bottom line and make all account managers more scalable through automation and prescriptive analytics, then we have succeeded. We can celebrate wins along the way, but we don't stop short of the outcomes that we are driving towards because we put energy and time into building this thing and we want to get full return on our investment. That's what we mean by going all the way to the right. Finally, let's talk about why you should consider adding a consumer insights function to your data team to harness the combined power of qualitative and quantitative data. Most data teams only deal with quantitative data. However, quantitative data alone does not tell the whole story. So let's walk through an example. In one market, Hudl has achieved a 98% renewal rate. It's easy to assume that this means 98% of Hudl customers in that market love using Hudl. Turns out this is not the case. Through qualitative research, we learned that 13% of the customers in this market have low repurchase intention, meaning that they are reluctant purchasers of Hudl and they would switch away if there was a viable competitor. This is a concerning finding, but it's not evident from looking at renewal data alone. Furthermore, qualitative research tells us that satisfaction with add-on products in this market is impacting repurchase intention. Satisfaction with add-ons A and B is high, satisfaction with C is low, and that's what's hurting repurchase intention. The insight here is that we can increase repurchase intention and create a wider moat against competitive pressure by improving the customer experience with add-on C. That's what I mean by combining quantitative and qualitative data to tell the whole story. To end this presentation, I want to show you the smart, hardworking people in decision science that I have the privilege of serving. They were excited that I would be sharing with you our story today and contributed in many ways to this presentation. And finally, please reach out to me on LinkedIn if you would like to continue the conversation. I look forward to connecting with and learning from you.